So hi everyone, I'm Eileen Jeng Lynch, Curator of Visual Arts at Wave Hill. Thank you so much for tuning in. We're so thrilled to have Alison Moritsugu here with us today in conversation. And to give you a little bit of background information, Alison Moritsugu creates paintings, sculptures, and installations. But today we're going to be focusing on specific paintings of hers. In these paintings, she's inspired by the Hudson River School painters and other 18th, 19th century landscape painting, but she is, by painting them on log pieces, she's really focusing more on the destruction of nature and the changing environment. Alison was born and raised in Hawaii and left the islands after high school. She has exhibited in many solo shows, including at the Honolulu Museum of Art at First Hawaiian Center, Lux Art Institute in California, Little John Contemporary in New York, John Michael Kohler Art Center in Wisconsin, and Knoxville Museum of Art in Tennessee. Alison also exhibited in the 2016 exhibition at Wave Hill, Survive, Thrive, and Alive, where she created a site-specific wall installation for the entrance foyer of Lindor Gallery. So thank you so much, Alison, for being with us today.
Well, thanks for inviting me, and thanks for inviting me to take part in this conversation. The work I do is really an exploration of idealized landscapes and sort of how those the images of those landscapes really shapes our view of nature and the environment around us. With the log paintings, as you said, they're Hudson River inspired landscapes, and I paint those directly on log slices. So it's this juxtaposition of an idealized image of nature, right up and right on, actually, real wood and real bark. And so the viewer sees this difference between what's real and what's not. And that's always intrigued me. I'm originally from Hawaii, and Hawaii is, you know, it's the main economy there is tourism. So from when I was a kid all the way to now, I've always, I've seen how tourism works in the islands and how tourism has shaped the environment and the economy. Also how people see Hawaii and their view of Hawaii is shaped by those sort of idealized images of Hawaii, the tourist state.
And so now I wonder if we can move on to the two ash paintings that will be in the show.
In fact, I have them on easels back here behind me. They're about 4 feet tall and about 2 feet wide, and they're really heavy. And these are painted on there's 77 growth rings on these log slices. These were painted directly on the logs. They're titled on the left, Remnant, and on the right, Vestige. And so again, Hudson River inspired landscape painted on an actual log. And, you know, it looks like an idealized image of nature, but when you look closely and on careful inspection, you'll see some things such as the woodpecker, the purple prism traps hanging from the top branches, the tree girdles that encircle the trunks around the trees, and insect galleries where the bark has been removed. And these are all signs of the emerald ash borer, which is an invasive insect that has decimated a lot of the ash population in North America. So that's what these images are about. The next image shows a detail of the side view of these paintings. So you can see the bark is still intact, and the bark almost creates a frame around the actual paintings.
And can you talk about how these paintings have changed for you during the COVID-19 pandemic?
Sure. I painted these in 2015, and I was about to drop them off at Wave Hill for the group exhibition at the gallery, and then everything went into lockdown because of COVID-19. And during that time, these paintings changed dramatically for me. Even though I didn't change anything physically, I didn't go back and paint anything different, but I ended up retitling these paintings. So I added the words "We are the ash" to the front of each title. And then I think the next image shows them side by side. So Remnant became "We are the ash, Remnant" in parentheses, and Vestige became "We are the ash, Vestige" in parentheses. And the idea here is I wanted to make the point that, especially since we are experiencing COVID-19, in essence, we are the ash. You know, we're experiencing a situation where a pathogen has entered our environment and we have no defenses or immunity to it. And so our whole lives have completely changed because of that. And it's not unsimilar to what's happened to the ash in North America. It's not unsimilar to what's happened to the birds, the honey creepers in Hawaii with malaria. You know, there's so many species globally that are close to extinction or extinct because of a sort of similar situation.
Yeah, there are so many parallels among those different situations. And one of the things that you noted was language or vocabulary.
Exactly. You know, as I've been following the COVID pandemic, you know, I'm sort of glued to the news online, and every day it changes. There's so many similarities with the vocabulary. And speaking of vocabulary, I thought it might be important to just go over a few words that we'll probably be using in our conversation today, which might help just to define what they are. The first one is emerald ash borer is often referred to as EAB. So I'll probably be saying emerald ash borer, and I also will be saying EAB. So that's what that stands for. Introduced species are species that have come from somewhere else and introduced to a new environment. Other terms that are used are alien, non-native, exotic, but I choose to use introduced. Invasive species are introduced species that have come to a new environment, but then cause harm to that environment. So not every introduced species is invasive. Just a very tiny percentage of introduced species that come to a new environment prove to be invasive. And
that's interesting because I've heard them interchanged or used interchangeably, but that's not necessarily the case. So.
Not necessarily the case at all. You know, and there's been a lot of talk amongst scientists and botanists, you know, to help make that distinction. The last term is cultivar, and a cultivar are plants that have been bred to have the same characteristics. So when you have a cultivar, what you lose in essence are the different variations in genetics and genes.
So here we have an image of the emerald ash borer.
I thought, yes, maybe we can go through some of the history of the emerald ash borer from when it was first discovered or it was first detected in 2002 in Michigan. So we're talking about 18 years ago. So I think it's just really important to keep in mind the time frame and the years of study and the years of detection. In terms of even thinking about COVID, you know, we're so quick to think that there's going to be a vaccine and everything will be fine, but so much involves collecting data and studying the pathogen to really figure out a treatment. So the emerald ash borer was first detected in Michigan in 2002. It most likely was in Michigan longer, but it took a while for it to be detected. They're not really sure where or how it got to Michigan. But they're suspecting possibly shipping crates or shipping material from China. And the emerald ash borer, its endemic native environment is northern Russia, China, Japan, and Korea. In those environments, in those countries, the EAB is a secondary pest. It has predators, so it really only attacks diseased and stressed ash trees. Once it came to the United States, there were no predators, so it just proliferated. In fact, once it got to Michigan, 99% of the ash trees in southern Michigan were destroyed, and it just reproduced exponentially. And so by 2013, over 8 billion ash trees in North America have been destroyed by the EAB. So that gives you an idea. It started out in Michigan, and then it just spread from there. In New York State, 20 to 30% of our forests are made of ash trees. Most of our forests are oak and maple, but the 20 to 30% are ash, and of that, 80 to 90% of those ash trees have EAB infestation. I think
what is the predator in its native country?
In the native country, the predator are parasitoid wasps. So there are wasp species in China that actually lay their eggs in the eggs and larvae of the EAB, and then when the eggs hatch, the larvae then, eat the host, which is the emerald ash borer. The next image is a 3D rendering, well, it's a 3D composite image from the New York State DEC's Forest Health Diagnostic Lab. So, they've been doing a lot of research on studies on the EAB in New York. So this is an image from that lab.
How large is the EAB?
It's about 1/8 of an inch to a half inch. So it's really small and tiny, and actually very beautiful, as you can see.
And you mentioned that the EAB affects different species of ash differently. Is that correct?
Exactly. Unlike a lot of pathogens, it doesn't attack everything equally, right? So with the EAB, the green ash and the white ash seem to be the most susceptible, and their populations have decreased dramatically because of the EAB. The black ash and the blue ash seem to be faring a little bit better.
And that's such a parallel with what's happening now with the pandemic.
Exactly.
It's affecting.
Exactly. It's just, another situation where you can't put a blanket statement. It doesn't cover everything. Like EAB affects all ash and kills all. It's just everything's so nuanced, and everything gets affected differently. And ash is really important to the environment. It's sort of it's key to the overstory, which is that area with canopy and above in a forest. And so when you lose the ash, you lose that overstory. More light comes into the forest and hits the ground, and then that causes, plants such as the honeysuckle to proliferate. And then you change the whole ecosystem. And then when you do that, you change the animals and the other insects and the birds that are part of that environment. And the other importance of the ash is it grows, the green ash grows in riparian areas, which are areas near streams and water. And the black ash grows in very swampy areas. And so when you lose those trees, you change the hydrology of the area completely. With the loss of the ash, it changes the water table. When there's more water, no other species can grow. And so, again, a huge change to that landscape. Okay, so once the ash was identified in Michigan and started to spread, one of the key difficulties was actually telling if an area was infected with EAB. What happens is when the EAB gets into an area, it's really difficult. There are no visual clues that something is wrong with the ash tree until the top of the ash tree's canopy starts dying back and the upper branches start dying back. And at that point, the tree is pretty much damaged and diseased and won't make it. So, the symptoms don't appear until that environment is in really dire straits. And so that was a real difficulty with first detecting the EAB in North America. And so this image on the left is a detail for my painting. In fact, these next few images, the detail of my painting will be on the left, and then the image on the right is the actual photo of an example of what for instance, here, insect larval galleries are. So the larva of the eastern emerald ash borer eats the cameo layer of the tree. And that's the layer that's the vascular system of the tree, where there's water and nutrients. And so the larvae eat that area and create these S-shaped galleries. And you can see that on the right. And then in my painting, I have that. When you look closely, the trunks of the tree show that as well.
Does it strip away the outer bark, or?
It does not. It lives in that area. And then once the tree dies, the bark falls off. And so on a dead tree, you can see these galleries. Again, you know, while the larva is in the tree eating away, you can't, because you can't see these, it's really hard to detect. Like, you're not going to go out into the forest and see these trees with these galleries. You know, it's going to look like a tree that's okay, except maybe the top branches are starting to lose their leaves.
I mean, even in the previous images we're looking at, you can't necessarily tell if they're healthy or if they're infested by the,
Right, because there's still leaves on the lower branches, you know, more in clumps. But the area on the right, the photo on the right, shows an area that's pretty much decimated by the EAB, but it's still green. So you know, there's another point to make. I think we're so used to going out, and as long as there's lots of trees and it's green, that environment, that ecosystem's fine. But it's like only until you study it closely do you see what's actually going on.
Sure, and it's been studied over, at this point, over a decade.
It's 18 years,
18,
So that's the time span we're talking about. So these images with the dieback of the overstory, and then the following images, the linguistic larval galleries, and then the next image shows woodpeckers. So what happens is when the eastern emerald ash borer does infest a tree, you tend to see an increase in woodpeckers because they feed on the larva. So in my painting, I included a woodpecker there.
So they could be an indicator of.
They are.
I mean, it's hard to say because woodpeckers don't live in trees, but.
Right, but they have, you know, studies have shown that when there is infestation of EAB, the woodpecker, there's an increase in population of woodpeckers. So again, if you monitor another species, it could help indicate the presence of the other species. So again, you know, another point, everything's all interconnected.
It definitely is.
And then the next image shows, these are purple prism traps. So you may have, you know, seen them in trees over the last decade, these big corrugate plastic folded prisms hanging from trees. So these were used early on to detect the presence of EAB. What they did is they baited these traps. So with a bait that would lure the EAB. They weren't used to eradicate the EAB, but they were used by scientists to detect its presence. So, you know, they would get monitored and checked, and if they found the emerald ash borer in the trap, that was a sign that this area was infested.
So what was specifically in the trap, and how do they decide that on the particular shape or color palette?
I'm not sure on the shape, but that actually is a really good point. They use a chemical that's sort of found in the ash trees to lure the insect to the trap. I'm not sure why that color, but I suspect it might be because it's so visible. I spoke to someone at the New York State DEC, and he was saying that they found that just the presence of these prism traps in the trees got people curious, got the public curious. So they were getting calls like, what is that in the tree and what's that all about? And it gave them the opportunity to start educating the public. So I think, you know, I don't know if there's a scientific reason for the shape, but in terms of, you know, a visual artistic reason, it's because it draws attention. And
Do you
sort of,
know if other artists have engaged in that way, in a sculptural method in terms of creating these? Or
I don't think so. I don't think so. But you know, another point to make is that, so you might have seen these about 10 years ago or 15 years ago. You probably don't see them much today because, unfortunately, EAB is in 80 to 90% of the ash trees. So it's no longer, they no longer need to figure out where the insect is and where it's not. They already know that. It's kind of everywhere in New York. So there's less importance on mitigating the EAB with detection measures like the purple prism traps.
so what are they using, or do they just assume that there's such a high percentage of them in the trees, or is there another tracking method that they?
Pretty much everywhere except some areas of the Adirondacks. You know, so the last 10 years they've been monitoring, detecting, and charting and figuring out where it is and where it's not. So they sort of have that information already. So the purple prism traps, and then the next image you'll see is something called tree girdling. And you can see a detail from my painting on the left and the tree being girdled on the right. This also was part of that early phase of detection. And so they've moved away from these early phases and they've moved into a third phase, which I guess we'll get into as we go through this. So tree girdling is when the outer bark is cut away from a section of tree. And what it does is it makes that tree, basically, again, bait, it makes that tree stressed. And that stressed tree then attracts the EAB. And so they come back and they monitor that tree, and then they remove the bark if they suspect it might have infestation. And if it does, then that trees in that area are infested with EAB. It's super labor intensive. You know, you've got to go out, you've got to do this, you've got to monitor the tree in the forest. But this was one of the ways of detecting the emerald ash borer. I think it all makes the point how difficult it is to detect, right? Like pulling away a section of bark and using it as bait to just try and figure out if the insect is there. You know, it's not like just swabbing your, I guess it sort of can be compared to getting a nose swab, right?
Right.
Detection, I think people forget detection in itself is very labor intensive. Just trying to detect whether something is somewhere or not, that's a big challenge in itself.
Right, and I mean that immediately makes me think of people who are asymptomatic, right? So
exactly. Exactly. Similar to the ash tree when it's first infested, because it shows no signs that there's any disease or anything, you know, unhealthy going on with it. Not until there's dieback of the overstory canopy and the upper branches, and by then the tree is, you know, very, very diseased.
And they're doing this girdling on specific, are the trees already unhealthy, or how are they selecting the trees to do this?
That I'm not sure about, but if the whole point is to make the tree stressed, they are probably, I believe they probably would be selecting the most, you know, the trees that are not the healthiest. Because when you girdle a tree, you actually end up destroying the tree. And so I don't think I want to pick the healthiest, sturdiest ash to do that. I don't think they do that. And so after the detection, trying to detect, you know, that phase of trying to detect where the EAB is, they've been developing over the years insecticides. So, you know, when I was first looking into this back in the late, you know, 2008 or so, they were just starting to develop insecticides. And now they've developed insecticides that you can either inject into the trunk of a tree or into the soil around the tree. You know, when you inject it into the soil around the tree, it does affect the water table. So injecting it into the trunk of the tree is a better solution. Again, similarities with COVID, one has to remember that a vaccine may not be like a polio vaccine where you get the vaccine once and you're set for life. You know, these insecticides that get injected into the tree trunk are good for 2 to 3 years. So every 2 to 3 years, the tree has to get re-injected with insecticide. And also the tree has to be healthy, right? If you start injecting an unhealthy tree, you're not going to have as much success. So the specimen itself has to be healthy. And the other issue is, yes, you can do this treatment on trees, you know, in suburban and urban areas and on private property, but you can't do that to every tree in the forest. So there's a limit to how effective overall this will be the entire ash population. Similarly to vaccines, you know, the challenge will be how do you give a vaccine to everyone, right? You're not going to be able to reach every single person. So sort of similar challenges again.
Right. So this insecticide is essentially mitigating the spread.
Yes, it's part of mitigating. Also part of mitigating the spread. What they did is they quarantined wood and cultivars from traveling. The EAB, their range of travel is about half a mile, you know, at most maybe 3 miles. So if we didn't move wood around or move plant specimens around, you know, the progression of the EAB would be a lot slower. What really sped it up is the fact that wood products get moved from one state to another, from one country to another, and that all of a sudden starts moving the insect hundreds and thousands of miles rather than by half a mile increments. What they did, New York State had a quarantine on the transport of wood, so you couldn't transport, for instance, firewood more than 50 miles from where the tree was logged. And then they also had regulations on wood that came from more than 50 miles. The wood would have to be heat treated, you know, with specific requirements such as amount of time of treatment and the temperature of the treatment. And I think they even have special sensors in the heating element that recorded data so they could prove that the wood had been treated to the same, you know, certain heat, a certain temperature and for a certain length of time.
So, this all sounds very similar to.
Doesn't it sound really similar? Yeah. You know, and so there was the, how do you get the word out about the quarantine? But here's what's happened. Because EAB has progressed so much, even the USDA, when I went to the website last, I saw, you know, a page saying we're kind of reassessing quarantine because we're sort of beyond quarantining now. It's sort of it's everywhere. So we're moving on to yet the next phase, which would be something like the parasitoid wasp. So these wasps are native to China. In fact, the federal government, scientists in the US worked with scientists in China to figure out what the predators were. And so they were these wasps. So there are, and this is all super regulated by the USDA. I think they have about 4 species of wasps that have been approved to be studied and released in really, really controlled situations in the US. And so what the wasps do is the female will lay eggs into the eggs and larvae of the EAB. And then when the eggs hatch, the wasp will eat the host, which is the EAB.
How are they keeping this population, the wasps, under control, so to speak?
Exactly, because again, it's like, oh, there's the solution, but then you have to think about all the different ramifications of that solution. So the wasps, they're first studied in the lab, you know, to understand what's really going on, and then they're then released in very controlled situations in the environment. For instance, just a certain amount of wasps are released into a very, you know, a particular area, and it's such a small population that they don't survive the winter. so that they can study it for that one season, and the winter kills them off, because the fear is that if they just release the wasp, they in turn could become invasive and a problem.
Right.
And the other thing to think about is, they still need to study what happens when these wasps eradicate all the EAB. Are they going to move on to yet another insect? And what is that other insect? It's like all this stuff you kind of have to think about before you just jump on a cure or a treatment.
Definitely. Or if you release these wasps, how do you control them, in terms of mating?
Exactly.
Or other,
Exactly. And so for now, I think they're using the small population. I think maybe over a certain population, then they will survive the winter, and then they'll be around for the next season. And how much will they grow exponentially from there? All that stuff's being studied and very tightly regulated.
Are they tracked? Are each of them tracked, do you think?
I'm not really sure the details on them, all that, but I think they probably are somehow. I just don't know what that is. It's similar to the vaccine trials that are happening. Everybody trying to develop one is probably given a list of specifications on that vaccine. What you need, what it has to do, what percentage does it have to be 50% effective, more or less. I think polio, the very first polio vaccine, was only about 51 to 54% effective. So, and also, for instance, with the vaccine, what happens if you give the vaccine to somebody who already has had COVID-19 previous? Right. All of that stuff needs to be studied as well.
Yeah, there's so many similarities as we've already discussed, including, you see here, the data tracking.
Exactly. The really big part of all this is educating the public. And I realized as I've been following COVID, going on the databases, New York's, Johns Hopkins, what's so important is that you disseminate the information in a way that the public can understand. And so it's just interesting how both have a dashboard. The CDC has a daily dashboard, and that's an image from today, 7/16. And on the right is the emeraldashboard.info dashboard from today as well. And you can see, the map of the US and what states there have been confirmation, detection of this pathogen in the state. And then, it just changes day to day, year to year. I was looking at the EAB maps in the US, and I remember just sort of seeing it in Michigan and Wisconsin. And then, a couple years later, I would look and, oh, wow, it's already in, to New York. And then it's just moving, growing. And now it's up to Canada.
Right.
But I think it's really important to have this kind of visual. I think it's very important the public see where it is, how big the area is. And without this information, you're just, working in the dark. So
that's how the governor is working on now. It's all based on data.
Exactly. Public policy and the economy, it's based on scientific data, which is so important. And there's parallels there between the two.
Certainly are. And then another way you'd mentioned is citizen science.
Exactly. So again, part of the public, educating the public, but also giving the public an action to do, right? So with the EAB and with invasive organisms and plants and animals, there have been some websites or apps set up where citizens, you or I, can go on and log in what we observe. So invasive.org is really a great app and website where you can go in and you can see, you can look for a particular species of plant and find out how many are in your area. Or on your walks, you can take a picture with your iPhone or your phone and upload and include data, for instance, how many species you saw in this area, descriptions of it. You can even log in, I think, what species you weren't able to find in the area. It all helps. Helps land managers and it helps scientists, and they do use this information to figure out where an invasive species is and where it isn't. Again, that big important question: where is it and where is it not? I mean, just
right.
And then,
are these available as apps as well, or is it you have to go to the website?
I have invasives you can have on your phone. I'm not sure about Feeder Watch. And that's put out by the Cornell lab. So Feeder Watch, again, citizens can log in and let them know what birds show up at their bird feeder. So this, this is this observation period that happens through the winter. So it helps figure out what's happening with what bird populations. Are they decreasing? Are they increasing? If there's a decrease, then it's a red flag to scientists to say, hey, what's going on here? Let's study this area or the situation. In fact, even the woodpecker in the previous slide, so they were able to discover that there was an increase in woodpecker populations where there was EAB, and they found that out in Feeder Watch, some data from Feeder Watch. Yeah, so again, I think what I was thinking during lockdown, it sort of dawned on me in the middle of lockdown, oh my gosh, we are just like the ash in the paintings I did. So we are the ash, but I was thinking we're not just the ash, we're the golden tree, golden toad, and we're the Hawaiian honey creepers. I mean, we're basically every species that we've been reading about over the last decades that are facing extinction, and just sometimes at home, it just seems like something happening in the tropics or on the island of Hawaii where so many endemic species are becoming endangered or extinct. And I think with COVID-19, it's just a reminder that, we share the same biology as other living organisms on this planet. We don't have special superhuman immunity. We share the same biology. So things that are happening to those species, it's foreseeable that it could happen to us as well. And it just sort of ties into the connection of everything. I think also, it really hits home that something that environmental scientists have studied and known that everything in an ecosystem is tied together, and you change one variable or you change everything. Sometimes everything's on a knife edge, right?
Right, yeah, we're all ecologically connected, socially connected. I mean, thinking about the pandemic and the protests,
it's
and this interconnected, dependency.
Exactly. So sort of the title just sort of reinforces we share so much with every living thing on this planet. We are them, they are us, we're all connected in a way.
Right, so which makes me think to take away that, we do one thing and it affects another. So they're all,
it's
cause and effect.
Yes, it's always been that way, but we don't see that, we just sort of, how can I put it? We do one thing, but it's affecting, the oceans in a certain way that we realize. And I just hope that we start realizing that every action, everything we say just affects more than what we realize.
I agree, big or small, there's impact there, so.
Special thanks to Andrew Randazzo. I spoke to him a couple weeks ago, and he, gave me a lot of information about what's being done in New York State with the emerald ash borer. And then their Forest Diagnostics Lab, who created that 3D composite image of the insect. And then bugwood.org and Forestry Images is a great resource for images of different insects. They have a wonderful library of images.
So thank you so much, Alison.
Well, thanks for having me and letting me talk.
It's been a great conversation, and I just want to thank everyone for tuning in.